In this example, we have ourselves a word problem. Let's read through it and kind of see what we got going on and what it is that we're looking for. So it says, as the sun descends behind a 150-foot grandstand, so here's our grandstand of a baseball stadium, the shadow of the stadium moves across the field. See the picture. Let L, this, be the line segment between the edge of the shadow and the sun. And so that's kind of perfect line of sight thing. So we're going to let the theta be the angle of elevation of the sun, so I can write that right. The sun, the angle between L and the horizon. So, all right, we're looking at this. This is kind of the ground. So we have some sort of an angle of elevation going on here. The shadow length S is the distance between the edge of the shadow and the base of the grandstand, right? And so as the sun is setting, that shadow is going to start to come across the field. That length is going to change, but our angle is going to change as well. So we are trying to figure out first, we're going to express theta as a function of the shadow length S. All right, so we're going to use S, we're going to use theta, and we're going to try to create some sort of a trig function related to that. Well, I don't know anything about L, I don't know anything about S. I don't want too many variables in here. We do know that that's locked at 150. So if I use 150 in S, because they want in relation to S and theta, then that is tangent. So if I write my equation, I'm going to express this as tangent of theta would be 150 over S. Now, I will tell you this whole time that my S's are going to look like fives. I apologize. I'm going to keep on telling you that that is not a 5, that is an S. All right, so when it says we want to express theta as a function of the shadow S, that means we want theta totally by itself. So our variable is S. We don't have theta totally by itself. So to do that, our theta is going to be an inverse tangent of the 150 divided by S. Try to make it not look like a 5. All right, so that is our equation in terms of S. So we've isolated the theta. So the reason we do that is we want to compute the change in your angle with respect to the change in your distance out. All right, so d theta ds when S is a very particular value. All right, so we want to know at a certain moment, we're not looking for what the angle is, we're looking for how the angle is changing at that moment, which is a rate of change, which is our slope. And then we'll talk about what that refers to. So let's find the math, do the math, and then we'll talk about the answer. So first thing is we need to do the derivative of this. So theta is inverse tangent of 150 divided by S, not 5. And we are going to do the derivative with respect to, excuse me, S. Right? So to do that, we're going to be doing an inverse tangent. So we have a formula for the inverse tangent, which is right here. So we need the U value. So our U is this. So we're going to do a little extra work here. So this is U for us. So 150 over S. And we're going to have to do, there's a chain rule applied to it. So when we do this formula, we're going to be subbing out U with our 150 over S, and then we're going to square it, but we're also going to be multiplying it by the derivative of that U. So we may want to rewrite this, because the way I have it right now, it's going to be a quotient rule. I don't really want to do a quotient rule. So if I rewrite this, I can have it 150 S to the negative 1, right? That's going to be, I think, much easier for us to do the derivative. So if we do the derivative, we are at negative 150 S to the negative 2, because we subtract a power. And if I want to rewrite that, we're looking at 150 over S squared. All right, so if I did the quotient rule, I would get that exact same answer, but it's a lot nicer if I don't have to do the quotient rule. All right, so there are our pieces. And so when I do the derivative, our d theta ds is going to be our formula. So let's go back to our formula. Our formula is this one right here. So 1 over 1 plus u squared, because we're doing the inverse tangent. So 1 over 1 plus u So 1 over 1 plus u, which is 150 over s squared, right? So that's that piece, and then we're going to multiply it by its derivative. So we're going to multiply it by its derivative, negative 150 over s squared. All right, so let's figure out some math here. We're going to have, well, so I'm going to not cheat it, but I'm going to try to take a little bit of a shortcut here because that is our slope equation. Do I really need to combine this and put all this stuff together? Not necessarily, because they want us to find this slope at a particular time or at a particular distance. So rather than me simplifying and trying to clean it all up, how about we just plug the 200 in for s, and then we'll start to clean it all up because it'll be easier rather than having to deal with the variables along the way. So if we're going to find our, when s equals 200, then our slope is going to be 1 over 1 plus 150 over 200. So I'm going to simplify that and then square it. And then times negative 150 over 200 squared. All right, so let's figure out some math here. So try to not use a calculator on any of this. So we're going to have a 1 over 1 plus, so I can cut a 0 out, and we're looking at 15/20ths, which will simplify to 3/4 squared. And then over here, this negative 150, I'm going to write this out as 200 times 200, because here I'm going to simplify one of them. So I'm going to cut a 0 out, which is dividing by 10. I'm going to take a 5 out of both of those. So that's going to become -3, and this will become a 4. So we're looking at 1 over 1 plus 9/16 times 800 negative 3 over 800. Right, that's what I got going on for that one. And then, excuse me, let's keep on doing the math here. We have 9/16, we're going to add 1, so really that's 6/16 instead of the 1. So we have 25/16. So 1 divided by 25/16 times negative 3 over 800. If I keep on simplifying that, we're going to multiply by the reciprocal. So I'm looking at 16/25 times negative 3 over 800. And I'm getting close to losing my ability to not use a calculator. So I can take a 4 out of this and a 4 out of this. I might even be able to take 16 out of that. So maybe actually I'll do a 16. All right, I got to use calculator. So I'm going to see if 800 can be divided by 16. Perfect. So 150. So our final answer is -3 over 125, just in case, 25 times 50, 1250. All right, so that's great, but let's try to make some sense of this answer. So I'm going to go ahead and actually divide this out. So I'm going to get a -3 divided by the 1250, and that represents a negative 0.0024 radians per feet, right? Which, again, let's make more sense out of that. Like technically that's the answer. We're going to want it in radians, but let's make it into degrees to kind of try to make some sense out of that. So that answer right there, if I'm going to convert it out of radians into degrees, I'm going to take that answer, multiply by 180 and divide by pi is how I'll convert it. So what that represents is a negative 0.138 degrees per foot. So at that moment, when that distance is 200 feet, this angle is changing by a negative 0.138 degrees per foot. Now, every foot it's going to be a little bit different, but at that instant moment in time, that's how your angle is shrinking, basically. So that's the radian version of it, and then that's the degree version, which makes a little bit more sense. So that is our final answer, but that's the answer that I'm going to throw into whatever software we're using. All right, and that was us doing a word problem related to inverse trig values.